Everybody, again, I'm Reece Cannady. I'm the manager of global trade at the U.S. Grains Council. I work out of the Washington, D.C. office. I've been there now about 10 months. So a lot of these faces are becoming more and more familiar as I go around and meet all of you. And if we haven't met, hopefully we can make some time tonight to meet each other and maybe talk about some markets and talk about the sorghum trade and really what's going on out there from a pricing standpoint, as well as maybe some barriers that you might have in your markets. Today, what I'm here to talk to you about today is the export system for sorghum. I think many people in this room may be familiar with the export system for corn in the United States, and the one for sorghum is not terribly different, although you will notice one major difference in that the barge system is rarely used. It's primarily a rail system throughout the United States. So first, you saw this earlier, but I wanted to use it again and show you exactly where sorghum is produced in the United States, and then it'll make sense why we don't use the barges. It's just simply too far away from the river system for that to be feasible on a large scale. So you see down in South Texas, you've got what we would call the early harvest, where we grow there in the coastal region, as well as down in the valley of Texas, where a lot of that, we'll talk about in a minute, gets exported by truck. And then we have the Texas Panhandle all the way up into western and central Kansas, and the Oklahoma Panhandle as well, where sorghum is also produced. And again, a big reason that this happens is because it is sort of a drought-tolerant crop, and it makes a lot of sense for it to be grown in those regions where there is less moisture. So today we're going to, again, talk about the movement of sorghum throughout the entire system. So we're going to start on the farm. I'll show you a quick video of a sorghum harvest that goes on. We'll talk about on-farm storage as well as country elevators. We'll talk about the subterminal grain elevator, which in this case will only focus on rail shuttle loaders. We won't talk about barge loaders. And then from there, we'll go to the export elevator, and then you load a boat and it heads out to the port where hopefully you, the waiting sorghum customer, will receive it. So first we're going to talk about the journey from farm to storage, whether it be on-farm storage or country elevator. Quickly, a show of hands, how many people in here have seen a grain harvest in the United States? Okay, perfect. I see a lot of hands in the United from the U.S. delegation, which is good. I'm really happy you guys have seen a grain harvest. It's very important. But I do plan to show a couple of pictures here so you can get an idea. Oh, now it wants to go. Okay. So this would be on-farm storage. So again, you notice this right here is a screw auger, and the screw auger essentially allows gravity to do all the work. The grain comes down at an angle of repose, where it's then picked up by the screw auger, which screws it up, and then the spout will dump it right into the truck right there. So with on-farm storage, you generally have a limited amount of bins. It's a bit difficult to do a whole lot of segregation, but the crop generally is pretty local since it's on-farm storage. So it doesn't vary in quality too terribly much. So farmers are content with putting it all in one bin. One thing to note about on-farm storage is it does have moisture control, so they are able to dry the grain if they need to. With sorghum, that's not as big of a worry because it generally does come off fairly dry. But they are able. They have fans and aeration systems attached to these on-farm storage complexes, and they're able to do that if they need to. Also, another thing that you might see at some country elevators is our ground piles. So ground piles with sorghum are quite common. We do see them quite a lot. A couple things to note on ground piles is they do generally have a concrete base. And the reason that we do a concrete base is so that when we scoop up the last amount of sorghum, you don't pick up any rocks, you don't get any kind of foreign material, and the grain can stay pretty clean for shipment. You'll also notice that there's a bunker system right there, a little wall system. It kind of helps keep everything intact. You will sometimes see tarps over these grain piles, but with sorghum, there are times where you don't have it tarped. It does do very, very well in the open air. It tends to form what they call a crust on the outside of the pile, which protects all the grain on the inside as long as the integrity of that crust is maintained. So next we'll move on from on-farm storage and country elevators to the next spot, which would be a subterminal elevator, which is where they can load trains and are able to send those trains all around the country, particularly to the Houston port, which is the main port of export for sorghum. So this would be an example of a subterminal elevator, or what you might hear referred to as a shuttle loader or a unit train loader. You see it has access to rail lines, and they can load up to anywhere from 100 to 110 rail cars at any given time. So when you get to these elevators, something I do want to harp on, throughout the whole system, the grain is constantly tested. So when it leaves a country elevator and it arrives at a subterminal, generally the country elevator will test it on the way out, and the subterminal will test it on the way in. So it's not only to ensure that contracts are met, so for contract specs between the two parties, but it also lets the subterminal elevators know exactly what they have, because they have more bins and they are capable of segregating even more, and they can put number 1 sorghum with number 1 sorghum, number 2 sorghum with number 2 sorghum, and number 3 sorghum with number 3, and so on. So it allows for the quality of the product to be maintained. It allows for the mix of products not to happen, so that you can that's how you can see at the end of the line with the international buyers that you're able to get an entire vessel of number 1 sorghum. It really starts here at the subterminal elevators, where they're able to do a lot of segregation. So when the grain comes in, they'll sample it, weigh it, and then inspect the sample as well. The method of sampling is important to note. Many of you have probably seen a probe system, whereas some of you perhaps may not. So in the United States, the trucks have 2 hoppers. They have a front hopper and a back hopper. And each time they probe, they'll take 3 samples from the front hopper and 3 samples from the back hopper, put them together, and they'll call that the composite sample for a truck, which they will then test. So now I want to touch on some of just sort of the logistics after it gets to the subterminal elevator on loadout. So we have really 2 areas of sorghum production, and that kind of affects the grain flows considerably. They have very different flows. So we have the early harvest, which is primarily down here in the coastal region and down in the valley, and there is a little bit of production in this area. And then we have the late harvest, which is primarily the Texas Panhandle and Kansas. So again, it's all pretty much flowing by rail when it comes to the late harvest. So the late harvest is going to happen around this region and in this region, and if you'll notice, these orange lines flow quite well to Houston without a whole lot of extra mileage. They come right down and come into the port of Houston, which is where the vast majority of sorghum ships out of the United States. So again, that's going to be the Houston port. And when we talk about early harvest, that's primarily going to be trucks. So the early harvest will be trucks that will either flow directly across the border to Mexico, across from the city of Progreso, or the trucks, if close enough, might even flow back into the port of Houston, where the port managers can load a vessel with a combination of rail from Kansas and trucks from South Texas and rail from West Texas. So these are rail cars in the United States. They have 3 hoppers on them, so they have 3 separate sections. One thing to note about the rail cars is the railroad system is fairly strict about the seals on the tops of these cars. So if the seal is not completely airtight and does not function, you can bad order a car, which means that you can send it back to the railroad and tell them that you're not going to use it. There's a problem with it. It has, it risks the integrity of the product by putting it in there. So it's certainly, when we're talking about rail shipments, we're talking about a very secure way to ship. Very little can happen in terms of quality degradation. So why do we do it? Why do we congregate into rail cars? Why doesn't everything just flow by truck? Well, I think the answer is pretty simple. It's just a matter of economies of scale. So why does it keep skipping forward on me? When you look at one Panamax vessel, so 50,000 tons, and you look at what that equals in rail cars, you're looking at 555 rail cars, which is roughly 5 shuttle trains, more or less. At the same time, that's 2,146 trucks. So from a logistics standpoint, putting together 2,146 trucks versus 5 shuttle trains not only is easier on paperwork, it's easier on staff, it's also easier to coordinate and ensure that you get the grain to the international buyer on time for when they ordered it. So next we're going to talk about what happens at the export elevator. So this right here is an export elevator. So what you have to pretend here is that there is storage on this. Why does it keep going forward? Okay. So the storage is over here, and that's where the grain begins. And from storage, the grain moves down a belt and into, again, what's called the boot pit. From there, it runs up a leg. And then at this point, once it goes up the leg and down here, it goes through the sampler and through a scale, and then over to the tripper. A quick note about the sampling. There's, at one of the facilities in Houston, for instance, they take a sample every 23 seconds. And that actually equates to, for a Panamax, that would equate with their rate of flow, that would equate to almost 6,000 samples. So that's a lot of samples. Those samples are then congregated into 50 equal-sized samples, at which point they are randomly divided until they get to, I believe it's a 100-gram sample. From there, they run all the tests. In fact, this shipping bin right here, once it goes through the tripper into the shipping bin, that gate is controlled by those who are actually administering those tests. And that's through the USDA FGIS, Federal Grain Inspection Service. So if something's happened to the grain, quality's been compromised, they can shut it off in a moment's notice without any problems. And because of this constant monitoring, it leads to a lot less logistical problems, double handling, having to unload boats in order to make grade. People tend to be able to get the product done on the first try without having to reload anything. So once it gets in the shipping bin, again, FGIS will then either allow the grain to flow through and onto the boat, or they'll shut it off. But assuming that they allow it to flow through, it goes down on another belt, out up the shipping belt, onto the galley, and through the spout and in the boat. So this is an example of an export facility. So this is actually the Zeno facility in New Orleans. This would be your shipping bins over here. This would be your longer term storage. Grain generally isn't stored there for terribly long, but you'd have your storage here in the back, shipping bins over here where it can then run and be loaded into the different holds. So this is a vessel loading right here. This would be the spout that goes down into the boat and raises up as soon as the grain hits the level where it is. It'll continue to raise up as the boat gets full. Again, I do want to touch on how we monitor grain movement at all times. So that includes when we're loading a vessel. When a vessel is being loaded, they're constantly monitoring it. It's a little bit more sophisticated than maybe a rail loader, in that they use computers to monitor all the quality rather than just sampling and testing. So they're constantly monitoring it through computers. It's got constant information. Information is updated at an almost immediate basis, and they really understand how grain is moving, flowing, and what the grade is that they're putting on the boat. And then after that, once it gets on the boat, it heads off to the international customer, where then they have their various mechanisms of unloading around the world.